Good morning, students. Welcome to Good Samaritan School online classes. In the last class, we were discussing on the uses of concave mirrors and also the uh, images which is formed, the formation of image of concave and as well as convex mirror. And also we learned the uses of convex mirror, some of the sign conventions for reflection for spherical mirror. So these are the things we have learned in the last class. In today's class, we are going to learn on the mirror equation. What is this mirror equation? As we know that mirror equation, it relates the image distance with object distance and focal length. So as we know that in a spherical mirror, the distance of the object from the pole, so we can, as we know that, so here I can draw it, and you know what is the name of the lens? This is a concave mirror. Okay, this is a concave mirror, and this is the pole. Okay, so the distance of the object from its pole is called the object distance. So we suppose this may be the object, and this is said to be the distance, and this is u actually. So the distance of the image from the pole of the mirror is called the image distance. Suppose the image somewhere it forms, maybe here or here, wherever it forms. So the distance between the image and from the pole is said to be u. See, I can't say that only here the image comes. It can come here or it may come here, wherever it comes. Okay, so the distance between the image and the object, okay, on the pole is said to be the distance between them is said to be the image distance. So and also we learned what is the focal length. So the focal length, as we know that the distance of the focal principal focus from the pole is called the focal length. Okay, this as we know before. So the relationship between these three quantities, what is the relationship? Image distance, object distance, and the focal length. So these three relations, we name them as mirror formula. So all these three are very, very important. So this formula 1 by u plus 1 by v is equal to 1 by f. It's very, very important because you're going to use this formula for almost all the mirror equation numericals. So it's very, very important. So you have to learn all these terms very importantly. So you should know it. U represents object distance, V represents the image distance, F is nothing but the focal length, and also you should know what is R. R is nothing but the radius of curvature, as we know before, radius of curvature. And you know the formula for that also, R is equal to 2F, and this formula. So all these things you should know, okay, before starting this mirror equation. Okay, the next thing we are going to learn is the magnification of a spherical image. Suppose you can know that when a mirror is kept, it may be a convex or concave mirror, and the image which is formed on it. Okay, sometimes the image which is formed is large, sometimes the image formed is very small. That is what we name them as a magnified image and also diminished image. So we name them actually when we are learning the previous topic uh, about the image formation on convex and concave. There we learned diminished image, large enlarged image. So that is we learned. So that means what? The measure of how large or how small an image is which represents to an object. अगर object 2 centimeter है तो sometimes when we are using a concave mirror, the object size enlarged, so it shows the enlarged image. Am I right? Suppose when we are using a convex mirror, the object becomes very small. So the image became very small. So it became very small image. So to find that or to measure it, we have a formula, and that formula is m is equal to h dash by h. What is this? H dash is nothing but the height of an image which is formed, okay, after reflection, okay. And then h is nothing but the height of an object that we are using now. So the magnification m is also related to an object distance and also the image distance. So what we are doing, instead of using h dash and h, we can name them as minus v by u. So you have to know what is h dash and h, and also you can relate m is equal to minus v by u also. So this is another very important equation that we are going to use for our next 3 or 4 numericals. So what I'm going to do is, we are going to do some problems, some numerical problems, and there we are going to learn even more on how to use these formulas and how we can derive uh, the numericals, and right. So we'll solve 2-3 problems by ourselves, and I will give you some more homework for you to do, and that you try it in your home so that you will get more expert on doing these numericals. Let us read this problem first so that you can understand how to understand the questions. Okay, so try to learn the question first. Okay, the convex mirror has its radius of curvature 20 centimeter. Okay, so it is a convex mirror. Convex mirror, it will be like this. Yeah? So convex mirror is bulged, right, like this. And the radius of the curvature is 20 centimeter. As we know that to find the radius of curvature, so if it is a spherical mirror like this could be the radius of curvature from here to here. So it is 20 centimeter, that you have to keep it in your mind. So this is how you have to look at the question. Find the position of the image of an object. So you should find the, yes, position of the image, right, placed at a distance of 12 centimeter from the mirror. So the object is kept at one distance. Okay, here every time you have to keep an object only on the left hand side. This is what the rule we have learned, right? So here an object is kept and it is 12 centimeter. So object is always represented by u. So what we should find? You have to find v. Am I right? So what is that? What are the things which is given here? R is equal to 20 centimeter, because it is kept on the right hand side of the lens, so it is measured as positive. You have to write these signs and all, is very important. And u is equal to, yes, 12 centimeter. So we can't write just like 12 centimeter, it is minus 12 centimeter. So what we should find? V. Find the position of an image, that image of an object, that we don't know. So how to start this? So since the r is given as 20, because r is 20, as we know that we can easily find the focal length, because r is equal to 2f. Am I right? So f is equal to what? F is equal to r by 2. I hope you understand this. Then what is r? It is 20 by 2, so it comes 10. What is 10? Plus 10 centimeter. So we know what is the focal length, right? So I know what is f, and also I know what is u. I need to find v. So use the formula. What formula we should use? Yes, mirror equation formula. Mirror equation formula is 1 by u or v plus 1 by v is equal to 1 by f. Okay, so what I should find? 1 by v find out karna hai. So take it on the other side. So when it goes u on the other side, it become minus. So 1 by f minus 1 by u ho jayega. So what is our next step? 1 by f, we know that f is 10, so 1 by 10 minus 1 by u kitna hai? Minus 12. So you have to write as minus 12. So take an LCM of this. So it comes, sorry, fella, we'll write like this, plus 1 by 12. So when we continue this, if you take an LCM and we do this, So it become 11 by 60. Okay, so 11 by 60 it comes. So that is 11 by 60 क्या है? It is 1 by V. So what is V then? Yes, V लिखेंगे तो ये उल्टा हो जाएगा, right? So 60 by 11 plus 60 by 11 centimeter. So this is the position of an image of an object, right? Which is placed at the distance of 12 centimeter from the mirror. So this is what the answer for this question. Clear? Shall we go on to the next question then? Okay, there is another problem. A small candle of 2.5 centimeter in size is placed at 27 centimeter from uh, in front of concave mirror of radius of curvature 36 centimeter. So at what distance from the mirror should a screen be placed in order to obtain a sharp image? Describe the nature and the size of an image. Okay, let's understand even more. A small candle 2.5 centimeter. Okay, the size of the candle is 2.5 centimeter. Is placed at 27 centimeter in front of a concave mirror. So let's draw a concave mirror. So concave mirror is somewhat like this. Okay, so this is the pole. 20, this is the image. Okay, this is the image. You think that. And इसका size क्या है? 2.5 centimeter. इतना छोटा है. Okay, 2.5 centimeter. And what is the distance is placed 27 centimeter in front of a concave mirror. Okay, this is kept on 27 centimeter in front of the concave mirror. And इसका radius of curvature क्या है? 36 centimeter. So ये 27 यहाँ पे है तो the radius of the curvature will be like this. So इसका distance is 36 centimeter, and here how this is how it is kept here at 27 centimeter. Okay, so these are the things which is there. At what distance from the mirror should a screen be placed in order to obtain a sharp image? So where I can keep a screen? If I keep a screen here, sometimes after reflection I can get a sharp image. If I move a screen like this, I can find a sharp image somehow here or here. So this is the question, where I can find the sharp image. Describe the nature and size also they are asking. Okay, so let's start that. What are the things they are given? So first we will write it down. So first they have given h is equal to 2.5 centimeter. What is h? That we have learned little before. That is, h is nothing but height of the object. Okay, height of the object is h. Here is kept. And because the height of the object is positive, why it is positive? Because it is kept above the line. You see that? That is also we have learned in the sign convention. When something is kept above, it become positive. Below आ गया तो it become negative. So that is why I am writing it as h plus 2.5 centimeter. Okay, height of an object. Then u is equal to minus 27 centimeter. Why u is kept at minus? U is nothing but the distance. Yes, distance from the concave mirror where it placed, right? So it is, because it kept on the left hand side, it should be written as minus 27 degrees, so minus 27 centimeter. And r is also given, radius of the curvature, as we know that it is 36 centimeter. Because it kept on the left hand side, it should also comes as negative, minus ही आएंगे. So from this even we can find the focal length also. Focal length, we know that r is equal to 2f. So f is equal to r by 2. So 36 by 2 it becomes 18. So this also you can keep. Okay, I can write it here. So 36, that begins 18 minus 18. That is the focal length. Clear? So we should find v. Okay, because image, they are asking image, so we should find v. Okay, let's start that. First we start with the mirror equation. See, as I told you, mirror equation is very important. You have to learn mirror equation. 1 by u plus 1 by v is equal to 1 by f. There is no big thing in this, so you have to learn this properly. Okay, as we know that u and f, we need to take this all in one side and the remaining on the other side, 1 by u. So this is now ready. They have put it all in the formula now. 1 by f is nothing but 1 by minus 18 minus 1 by minus 27. Clear? U substitute हो गया and f को भी substitute किया. Clear? And then what you should do? If you take even the same thing, same procedure, then v will become minus 54 centimeter. I think this is a simple equation. When from 6th standard you are learning this. So v is equal to minus 54 centimeter. Okay, this up to this we find only v. That means image only. There is and the question is, describe the nature and size of the image. What is the nature? Nature and size क्या होगा? So to find the nature and size, further we need to move. There is another formula that also we learned in the last class. M is equal to h dash by h, is that nothing but minus v by u. This is a formula. We can even find the nature. You can see the image, measure how large or small, right? Size find out करने के लिए a formula हम use करेंगे. So formula is m is equal to minus v by u. So as we know that what is v? V is here. So it's minus 54. Already one minus is there in the outside. And u क्या है? U is there already, we know here. So it is minus 27. Clear? So as we see that it becomes minus 2 because minus is already there. So minus 2. What is m now? M is minus 2. So and also we have another formula. M is equal to h dash by h. Sorry. H dash by h. What is this h dash by h? This h dash we have also learned that height of an image. That means height of the image. And h is nothing but height of the object. Height of the object that we learned in the starting, candle का size क्या है? 2.5 centimeter, right? Height of the image we have to find now. Already we know what is m. M just now we find it is minus 2. And h dash, height of the image, that we don't know. And height of the object that we know already. In the starting itself we learned it is 2.5 centimeter. So we just put it here, 2.5 centimeter. So since it all ready, so we need to find this, then put it all in the one side. So h dash is equal to, take it on the other side. So minus 2 into 2.5. So it becomes 4.5, approximately minus 5 centimeter. So h dash is nothing but minus 5 centimeter. Okay, what we are finding from this? This is the height of the image. Okay, image का height मिला मुझे. पहले image object का height क्या था? It is 2.5. Image कितने? 5 आया. So it begins छोटा object, it looks bigger. Okay, double the size आ गया. So it is actually magnified. Magnified. Will you understand? So this is the one thing. What is the second thing here? Because it comes minus, you have to know one thing. I just want to take all of you take your book, because it's very, very important to identify that. Whenever a negative sign in the value of a magnification indicates that the image is real. When so always minus आया तो the image is always real, and positive sign आया तो the image is always virtual. So you should not forget this. Sorry, I didn't tell you before. So these two things is very, very important. That means Whenever a negative sign it comes, it means they are always real, and the positive sign is always virtual. Now come back to that same problem. Now our problem is -5, so it is actually a real one. And then in always you see that because the this is we have taken a concave mirror, it should always as an inverted image. So these are the nature and size of the image which is formed. Okay, student, and these two problems, that means problem 3 and problem 4, which I'm going to give you as a homework. You try in your home, solve this. This is two are simple only. It's not a difficult one. You can simply use the for this third problem. You need not to use the even a mirror formula. You can use the simple formula m is equal to, right. So it will be an easy one. And another one, what we are learning problem 4, we can use the simple mirror formula and find it. Okay. And if you have any doubt on this topic, what we are learning, please do ask me in my WhatsApp number. Thank you and have a nice day.